Hey everyone, today we're taking a look at solving our quadratics by completing the square, and so we'll be picking a couple of examples of each line, and then the second topic will be solving other polynomials, mainly by factoring. So that's what we're covering today. So we're starting off by just remembering the three main steps we need to go through when completing the square. Step number one, divide every term by a, that leading coefficient. Then move the constant term to the other side. And third, we're going to add the special number to both sides of the equation, this b over 2 quantity squared. Those are the first three steps to get us going. There are some other steps beyond that, but that's how we start off by completing the square. We'll take a look at a couple examples where this b is even and then where b is odd, because that is what creates some odd fractions for us. So let's start off with this first row. Step number one, divide every term by a, your leading coefficient. It's already 1, so if I divide everything by 1, nothing changes. Next, let's move that constant term to the other side. Remember to change the sign when you move it over, because we're subtracting 5 from both sides. Next, we have to figure out this number, this b over 2 quantity squared. So my value of b is negative 8. So I'm thinking of negative 8 over 2 quantity squared. That means we are squaring a negative 4. That gives us a positive 16. So we are adding 16 to both sides of the equation. That means on the left-hand side, we now have a trinomial that can be factored. And so if you think about this, we're going to find factors that multiply to 16, but add to a negative 8. So we match the sign in the middle. And because those are identical, we're going to rewrite that as a binomial squared. Okay? On the right-hand side, negative 5 and 16 gives me 11. Now, again, our goal is to solve the quadratic. We're trying to solve for x. So our next few steps are going to work to isolate the variable. We'll start by taking the square root of both sides, and don't forget the plus or minus. So we have x minus 4 equals plus or minus root 11. And then move that negative 4 to the right-hand side. We're adding 4 to both sides, so 4 plus or minus root 11 is that final answer. All right, let's do another one. Take a look at part B. Here we have our quadratic, but this time we have a leading coefficient of 4. So we're going to start off with this very first step and divide every term. Essentially what we're doing is we're dividing the left-hand side and we're dividing the right-hand side by 4, and we are reducing where possible. So 4x squared over 4 gives me 1x squared. Positive 8x over 4 gives me plus 2x. Here we have just 1/4, and the right-hand side is still 0. So next we're going to move that constant term to the right-hand side. Again, remember to adjust your sign when you move that 1/4 to the right. Okay, so now we have to think about what that b over 2 quantity squared will give us. Our current value of b is 2, so you don't use the original, you use the updated value of b. So this is a 2. So 2 over 2 is 1. We're going to square that number and we get 1. So we're adding 1 to both sides of the equation. Now on the right-hand side, we want to make sure that we create a common denominator so we can add those fractions with a denominator of 4. Let's factor the left-hand side. That will give us x plus 1 times x plus 1. So we can rewrite that as x plus 1 quantity squared. On the right-hand side, I have a negative 1/4 plus 4/4, and that'll give me a positive 3/4. All right, now we're ready to extract the x, so we're going to extract the roots. So don't forget the plus or minus. We have an x plus 1 on the left-hand side. And on the right-hand side, we do have a perfect square of 4 in the denominator, so we will have the plus or minus root only over the 3, and the square root of 4 will give us that 2 that you see in the denominator. So lastly, I'm going to isolate the variable by subtracting 1 from both sides. So negative 1 plus or minus root 3 over 2. And we'll leave our answer like that. All right, so now let's go down and take a look at a couple of examples where we have a value of b that is in fact odd. All right, so that'll make our fraction work a little more challenging. So here we go with letter D. So this is a 2x squared plus 5x plus 7 equals 0. Step number 1, let's divide every term by 2. All right, so we end up with x squared plus 5 halves x plus 7 halves equals 0. Okay, well, that doesn't look very nice to have those fractions in there, but we can do this. Our next step is to move the constant term over to the right-hand side. Remember to change the sign when you move that to the right-hand side. So now we have to figure out what to add to both sides, and this is where we bring in that b over 2 quantity squared. So I need to use this space right up here just to kind of work this out. So again, we want b over 2 quantity squared, but my value of b is a 5 halves, so it looks like 5 halves over 2 quantity squared. So if we have fractions inside fractions, turn that denominator of 2 into 2 over 1. So it's 5 halves over 2 over 1. And that way we can replace that division with multiplying the reciprocal. Right? So instead of dividing by 2, we're multiplying by the reciprocal of 2. So it's 5 halves times 1 half, and that will give us 5 fourths. So when we square that, we get 25 sixteenths. So that's what we're adding to both sides. 25 sixteenths is what we want. And on the right-hand side, notice that we don't have a common denominator, so I need to multiply that negative 7 halves by something so I can create a common denominator of 16. So we will want 8 over 8. That's my multiplier. So there's a couple of issues going on here. We have to think about how we're going to factor this. So we have a fraction here. That means we're going to set up fractions in our factors. And I'm thinking to myself, I need a numerator times a numerator that gives me this 25 on top. So we want 5 and 5. And then we want denominator times denominator that gives me that 16 on the bottom. So 4 and 4. Again, they have to be the same number. And that middle term is positive, so these are also positive. So that means we can group up this as a binomial squared. So x plus 5 fourths quantity squared. On the right-hand side, we now have a fraction that is going to have a denominator of 16. So this is negative 7 times 8. So negative 56 over 16th plus 25 over 16th. Now that we've got the common denominator of 16, we can add the top. So negative 56 plus 25, I think that gives me negative 31. So when we take the square root of both sides, notice we will have the square root of a negative. We're going to turn that into our I. So we're factoring out the negative 1 away from the positive 31. So x plus 5 fourths equals plus or minus. I don't want to forget that plus or minus on the radical. Here's the I that came from the square root of the negative 1. There's the 31 that is left under the radical, and then in the denominator we have a perfect square, so the square root of 16 gives me 4. And last step, let's subtract the 5 fourths from both sides to isolate the variable. So x equals negative 5 fourths plus or minus. And then I want to clean this up because since I have a common denominator of 4, I might as well combine them over a common denominator of 4. And we typically format this with the I in back. So it would look like negative 5 plus or minus root 31 times I. So that's a bit of a strange case as we ended up with an imaginary answer. So let's do one more of these and we'll take a look at part F since I've got room over here. So we have a 3x squared plus 7x minus 1 equals 0. Step number 1, divide every term by 3. All right, so we have x squared plus 7 thirds x minus 1 third equals 0. Again, move that constant term to the right-hand side. So x squared plus 7/3 x equals positive 1/3. So again, watch your sign as you move the constant term to the other side. So now we have to figure out what to add to both sides. So I'm using my thinking space right over here. I want that b over 2 quantity squared. And so my value b is the 7/3. So we have 7/3 over 2 over 1. All of that has to be squared. So we want to set this up as 7/3 times the reciprocal of 2. So 7/3 times 1/2. So that will give me 7 over 6. We're going to square that number, and that's going to be the number that we add in. So it's going to be 49 over 36. All right, so that's the number we want. So we're going to add in 49 over 36. All right, so as crazy as that fraction sounds, we can factor this using that pattern of creating a binomial square. We want x in front, we want a fraction in the back. So we're thinking, what numerator squared would give me 49? Let's use 7. And what denominator squared would give me 36? We want 6. Match the sign in the middle, so that's a positive 7/6. Now on the right-hand side, we don't have that common denominator. So I need to multiply that 1/3 by something so that we have a common denominator of 36. So I'm going to multiply that by 12 over 12. So that means let's see if I can fit this in. We want 12 over 12. So that means we have 12/36 plus 49/36. So that's what we're looking at combining, and so we end up with a fraction of 61 over 36. So now we'll take the square root of both sides. Don't forget the plus or minus. So x plus 7/6 equals plus or minus root 61 over 6. Again, that denominator is a perfect square, and so we can turn that into a 6. Let's isolate the variable. So we're moving that 7/6 to the other side. Don't forget to change the sign. So negative 7 over 6 plus or minus root 61 over 6. And again, we do have a common denominator here. So I'll go one step farther and create negative 7 plus or minus root 61 all over a common denominator of 6. There we are. Okay. So those are the first few examples involving completing the square. Let's take a look at a couple of these next examples that have to do with solving other types of polynomials, and that is meaning usually by factoring in these cases. So let's look at a couple instances here. Here I have this polynomial of x cubed plus x squared equals 12x. I want to first start by bringing all the terms to the same side, and then remove a common factor if possible. We can remove a common factor of x. That leaves us with x squared plus x minus 12. And now that I have a trinomial, I would like to factor that trinomial into two binomials. So we want factors that multiply to negative 12, but add up to positive 1. So positive 4 and negative 3. Each of my factors are multiplied, and the whole thing equals 0. So x equals 0, or x plus 4 equals 0, or x minus 3 equals 0. As a result, we get 3 answers. So we solve for x in that case. Remember that when you have 4 terms, we want to factor by grouping. So we're going to pair up the first 2 terms and the last 2 terms and extract the common factor of each. So out of the first 2 terms, I can factor out a 2 and an x squared. So I have a 2x squared, and there's an x minus 2. I'm sorry, that's not a 2. That's got to be a 1 remaining inside, because if I distribute the 2x squared back in, 2 times negative 1 gives me that negative 2 that we see right there. In the second pair, we factor out a 3, and that leaves me with an x minus 1. And here's your check step. Again, we want to make sure these two are the same. And if the binomials were different, that would tell us that we had done something wrong. Now we remove the common binomial. So we're factoring out the x minus 1. and what's left over is the 2x squared and the positive 3. So these are the factors, which means we're going to split those up. So x minus 1 equals 0, or 2x squared plus 3 equals 0. So there's one of our answers, x equals 1. This other one, let's work to isolate the variable. I'm going to move the constant term to the right-hand side. So again, watch your sign. Then let's divide away the 2. So x squared equals negative 3 halves. And then we're taking the square root of both sides. Don't forget your plus or minus. And again, we have that negative 1 in there that will turn to the imaginary I. So we get x equals plus or minus that square root of 3 halves. And we have an I floating around here as well. But we can't stop here. We can't leave it in this format because we can't have a radical in the denominator. So we're going to rationalize the denominator by multiplying top and bottom by root 2. So this is just to adjust the format here. So that means we're going to have x equals plus or minus root 6 over 2 times I. So we have 2 answers with the plus or minus. We have 1 answer from the positive 1. That's 3 total answers, and again, that matches the power of our 3rd degree polynomial. So I want to go to one final example that's on the next page. So if you give me a moment to just turn over, this is page 16. There's a couple examples at the top. I'm just going to pick one of these as well. Just because we have a 4th degree polynomial, I want to show one of these. So we'll just take example 4 here, the first one. And what we have is we still have a trinomial. All right, so because we have a trinomial, we could still factor that into 2 binomials. So I'm using a guessing and check approach. So what times what gives me the x to the 4th? Well, that would be x squared times x squared. And then what times what multiplies to 2, but adds up to a negative 3. So we want negative 1 and negative 2. The point of this is we're going to get 2 answers out of each of these factors. As we separate the factors here, setting each factor equal to 0, then we're going to work to isolate the variable in both cases. So x squared equals 1 and x squared equals 2. And then when we take the square root of these, don't forget the plus or minus. So we're going to get 2 answers, plus or minus 1, and then another 2 answers, the plus or minus root 2. So we have 4 total answers, and that matches our 4th degree polynomial. And that's our topic for today.